again, doing another video on stuff. Now, I made it bigger this time. Hopefully that'll help, because I had criticism last time that it was too small and we couldn't read it. So here is CC 11B.3. This is about metal extraction. Now, it gives you a reactivity series there, okay, including carbon. Now, we should remember this means anything below that we can extract using carbon. So, first of all, metals are extracted from ores. What is an ore? Right, it is a rock that contains enough metal to economically extract. Basically, it contains more metal, more value of metal than you'll get, than it costs you to extract it. Right, which metals occur uncombined in the Earth's crust? That would be gold. Okay, they're found on their own. Metals are usually extracted by heating metal oxides with carbon or by electrolysis. Predict which method is used to extract the following metals. Now, if it's below carbon, okay, here, we use carbon. If it's above carbon, like there, we use electrolysis. Now, we'll find out what electrolysis is, how it works later on in the course, but right now you just need to know it's a way of extracting metals. Now, magnesium is above carbon, so we would use electrolysis, and lead is below carbon, so we would use heating with carbon. Okay, now explain why aluminium cannot be extracted from aluminium oxide by heating it with carbon. Okay, aluminium, I'm going to resist temptation to say it. We're going to use aluminium is above carbon in the reactivity series. It's too reactive. Now we can use it there because, of course, it directly linked to something you spoke about earlier. So you've said it's aluminium is above carbon, it's too reactive. That suggests you're talking about aluminium, okay? You can't just start with it because you need to say what you're specifically talking about. Iron could be extracted from iron oxide with electrolysis or heating with carbon. Why is it better to use heating iron oxide with carbon? Carbon is cheap and easy to obtain. Remember, you could Remember, you could just go outside, find a bit of a branch, find a bit of wood. There's your carbon, easy peasy. Okay, now it says zinc can be extracted from zinc oxide by heating with carbon. Write the word equation. Okay, so extracted from zinc oxide by heating with carbon. Okay, so we've got zinc oxide plus carbon. What's that going to make? It's going to make zinc, because you're producing zinc. And what's left? We've got carbon dioxide. Now we write a balanced equation. So zinc is ZnO, that's zinc oxide. Carbon is obviously just C. Zinc is just Zn, therefore. And carbon dioxide is CO2. So we need to balance this. We'll start with the O's, nice and easy. We've got 2 on this side. We've only got 1 on this side. So what we need to do is we need to have 2 zinc oxides, that's the worst 2 ever. 2 zinc oxides, that gives us 2 oxygens, okay, on both sides. We're now good. Let's now look at the zincs. We've got 2 times 1, which is 2, and then 1 here. Okay, so what you need to do is put a big 2, that's a better 2. In front of that one, gives you 2 of that. Sorted. Right, that's sheet 1 out of the way today. I will scroll past all these lovely other sheets you have that we haven't looked at yet. Okay, and we're going to think about redox reactions. Lovely. Okay, so we're going to think about whether something, first of all, has been oxidized or reduced. Okay, so aluminium oxide has been oxidized. No, hang on. What's he on about? It's been reduced. And that's because it's lost oxygen. Okay, oxidation is where something gains oxygen. This has been oxidized. Why? Because the nickel has gained oxygen. Carbon plus zinc oxide becomes zinc. Well, this has lost oxygen, so it's been reduced. So it's lost oxygen. Iron oxide becomes iron, so again, it's been reduced because it's lost oxygen. We're seeing a pattern here. Chromium oxide to chromium has been reduced because it's lost oxygen. Copper becomes copper oxide. That's been oxidized because it's gained oxygen. Copper oxide becomes copper. That's been reduced because it's lost oxygen. Calcium oxide becomes calcium. It's been reduced because it's lost oxygen. Hydrogen becoming water. Well, that's gone from H2 to H2O. It's been oxidized as it's gained oxygen. Magnesium plus iron oxide. The magnesium becomes magnesium oxide. It's been oxidized as it's gained oxygen. Right, 2. Lead oxide reacts with carbon to form lead plus carbon dioxide. So, it tells us that lead oxide reacts with carbon, so plus carbon, to form lead plus carbon dioxide. Nice. Okay, so PbO is the formula for lead oxide. Carbon is just C. That will form Pb plus CO2. Now you'll notice this follows the same structure as the zinc one we did earlier, meaning we need 2 of these because now we've got 2 times 1 oxygens on this side and 2 oxygens on this side. We now need 2 there because we've got 2 times 1 leads here and 2 times 1 leads here. Now what has been oxidized? The carbon, because it's gained oxygen. What's been reduced? The lead oxide. This is because it's lost oxygen. Okay, the half equation occurring at one of the electrodes during the electrolysis of molten magnesium chloride is that. State whether this is oxidation, reduction, or neither. Now, for this, we've got to remember oil rig, i.e. oxidation is loss, reduction is gain. It says it down here, okay? It says down here a bit. So oxidation is loss, reduction is gain. Now, the Cl minuses, okay, have lost electrons because they're now over here. Okay, so these have lost electrons. So this is oxidation. Okay, oxidation. Now, which electrode does this occur? It's the anode. Okay, job done. Right, thank you for watching.